Adam, I would love to cover signed extensions or custom origins. Adam, that's awesome. Those are two things that I've really been wanting to learn about. So let's do those for sure this this hour. Hi, Boneyard. Welcome.
Gentlemen.
All right, looks good, Steve. I can see it.
Yeah, okay, awesome. You can also see when I'm changing desktop. Yeah.
Yes.
Cloudsmith and code.
Okay, awesome.
Yeah.
GitHub.
So yeah, so I'm going to like do a quick demo of a little tool that I've been working on. There's still some rough edges, so bear with me. I will explain you what it can do. So it's called Substrate Deps. And the idea is that it provides you some command to help you work with and manage the modules that you have in your Substrate runtime. Okay, so currently you have like two commands. The first one is add, to add a new runtime module, and it's meant to be used with modules that have been published to a create registry. Well, right now it's not possible to publish a Substrate runtime module to crates.io, but I hope it's going to be possible very soon. So for the moment, I've been working with an alternative registry that I have set up on something called Cloudsmith, and I will show that to you after. And basically the idea is that when Polkadot is available and Substrate also reach like the next milestone, is that we want to have teams and developers building reusable runtime modules, and they can share them, and we can easily find them and compose them, right? And well, that tool will allow you to easily link with all the modules that are available. The next command is a graph command, and it will allow you to output a dependency graph of all the modules that you're using in your runtime. To be honest, I don't know if that's full, but I find it very insightful for myself. Modules that you can use, and it's also a pretty big code base. So just from a learning perspective, I find it.
Yeah, I'm pretty excited to see it. Actually, it sounds super. So is it all of the like Rust modules that go together to make Substrate, or is it like the runtime modules?
So yeah, so currently I limit that only to the runtime modules.
Okay. Cool.
But it's just very an arbitrary limit that I set. But yeah, I can show it to you. The sound is a bit cutting. I don't know if you can hear me well.
Yeah, it's
a bit noisy, but yeah.
You hear you pretty good, but there's other noise now.
So yeah, so I will start with the graph command. So you have to point it to the manifest of your cargo tunnel. So let's get the right path here. That's it, and I should have a graph file. No, I will do it in maybe in the. Yeah, there you go. So I just ran it on the basic Substrate node template. So there isn't much in there, but with that you get a view of your runtime and like the default modules that are being used and the dependencies between those modules. So yeah, I find it useful. Yeah. But be aware that those are only the module dependencies. So what we don't see, as Sean was very careful to point out to me, is that we don't see the indirect dependencies that we can see when a module is being configured with another one through the trait object. So those are only module dependencies, but well, this is already, I think, useful. Yeah, probably an improvement would be to also.
Yeah, it already, let me
It,
just stop and say, like, Steve, this is already super helpful because I'm seeing patterns here. Like, we see that node template runtime depends on pretty much all the modules, which then depend on system. And for many of them, that's the path, like node template runtime pseudo to system, or node template runtime to indices to system. But a few of them have like a more complex thing there, like this session thing depends on timestamp, and the consensus stuff depends on session. So yeah, like super helpful.
So I also read
guys,
it on
sorry, could you repeat a bit what do you mean by indirect dependencies?
So let maybe go in the lib.rs of the runtime. Let's take yeah. So we have like a configuration trait for pretty much every runtime module, and in that configuration trait you can configure some types, some values, and sometimes you're basically plugging in a type or a trait from another module. Okay, so those kind of indirect dependencies don't appear on the graph.
Yeah, a common example is the balances module implements this type of currency. And so pretty much any module in Substrate, which depends on you being able to access the currency of the system, gets is that account here, for example, in indices, it is pulling something from balances. So there should be, you would actually see a lot more dependencies on this SML balances trait if it was correctly finding everything. Because you
So
like this
you mean here is so the separation of direct and indirect is based on criteria of visibility or on criteria of like value or interface?
So currently, it's only based on the dependencies that are declared in the cargo.toml manifest of the module. Yeah.
So only those dependencies which you declared with use keyword.
With only those that are in the cargo.toml will be displayed here.
Right.
And yeah, I was going to so I ran it on Polkadot. So on the Polkadot runtime, it's obviously a bigger graph, but it's still, I think, interesting to see already the direct dependencies. So that is first thing, and for that I'm actually using a tool called Cargo Deps, which is a basic tool for Rust dependencies. So I had to submit a PR so that it could be used as a library. But it's already also useful in the code itself of the Substrate Deps tool, because we then gain like an understanding of the dependencies of the different modules, and this is kind of groundwork for some future works that we want to do for tooling for like a front end, web front end, to allow to search for modules. So having an understanding of those dependencies is super useful. And so, yeah, so the next command is add. Yeah, so I have like turn off series. I have a module called SCML template module. It's basically the template module that I published on an alternative registry. So here I basically say I want to add that SCML template module to my runtime. I'm going to give it an alias of templates, because typically we don't use like the full name of the module in the code. And I'm fetching it from a registry that is called Substrate mods. So what it's going to do is it's going to contact the registry, gather information about that module, read the metadata, read the dependencies of that module, and add it to my runtime, and also add all the depending modules.
So the command you did there, so -- registry, that like your hope is that at some point that can be like -- registry crates.io, or that could be like the default.
Yeah.
Okay.
That's,
and the
alias, mention it right. Yeah. So basically, yeah. Sorry.
Go ahead.
So yeah, in my cargo config file, I have configured like an alternative registry. So in your .cargo config file, you can Like this is the default stuff for Rust. And for Cargo, you can define alternative registries. From what I understand, it's not very used yet, because I have seen a lot of tools that deals with cargo dependencies, stuff like that. They're not already up to date for alternative registry. So that's why it's a bit difficult to build something that deals with all that stuff. But as you said, at some point, everything will be on crates.io and it's just going to be working. So,
and can you tell us about -A and -V also, or maybe now is not the right time? That's fine too.
So, yeah, what I'm going to do is Substrate Deps, and then you will have everything here. So -A is to give an alias to the module you're adding. Yeah, V is just for verbose outputs.
So when does that alias get used? Is that like what goes in construct runtime?
Yes. So now that I ran that command, if I go check my cargo.toml, I should have wait a minute. Traits. Yeah, I didn't pass. Manifest path. All right, that's better. So it should have, so I still have like a few formatting issues. It has added the template module here. It also actually has added the balance module, but we already have it, so it shouldn't add it a second time. So let's remove it for now. It has added my my module here, and it's actually referencing it from the registry. Again, I have the balance module. A second time. So this is yes here, and then in my lib.rs, just before my construct runtime, I should have my configuration trait for the template module. Again, I'm removing that, and it also has added the template module here. All right, does that make sense?
Yeah, that's great.
Okay, and so there's still a few rough things, but basically what I have kind of defined in so this is like the template module, and I have defined some metadata in the Cargo toml of my module that I published, that you put in a section called package.metadata.substrate. And in there, you have a bunch of things. So there is like a default alias that you can put, template, for example. Let's say a compatibility version for substrates, a bunch of categories. If we see a bit further that we want to kind of organize those modules in different categories, then this will be able to build a front end for that. And then I have basically a bunch of default settings for the modules that my module here is depending on. Let's say I want to use this module and I want to get the default configuration for the balance module that it needs. So those metadata will allow to generate the code. So when I say balance here, it's actually gonna fill in the blanks here for the currency type in the configuration trait, and this will basically fetch the balance runtime module from Substrate. Okay, this is for the triggering that will go in here. Sorry, and this is basically for this part. So obviously this is not ideal because you have to kind of redeclare a few things. I hope probably to be able to get rid of those things, because I will be able to inspect the code and kind of infer everything from the configuration trait of the module. But for now, yeah, I'm using a few metadata.
Some people,
what?
Oh yeah, go ahead.
Yeah, may I ask a question? Probably I lost thread. But what is defaults? Like
Yeah,
so
right here.
no, in cargo toml.
So what I just showed here.
Yeah, like.
So those are a bunch of custom settings.
Mm-hmm.
If you want, in a custom section that I have defined, that I'm using in a Substrate Deps tool to be able to kind of generate code, configuration code.
So we generate code by our core cargo toml.
Yes. So from the metadata that you add in the cargo toml of your custom module.
Ah, so it's not only analyzer.
So no, no, indeed, it could be there. It could get there.
Okay.
But yeah, you have to see. For example, in my module here, I declare like a currency setting in the configuration trait. If I don't have metadata, then yeah, I can add the module to your cargo toml of your runtime, but that's basically there. And then you have to manually yourself fill in the blanks, which I think it would be interesting to be able to fill in like a default configuration using maybe core runtime modules. So that's what I'm trying to do. But yeah, if that doesn't make any sense, please give me feedback, and I am iterating on this tool. And
yeah, this looks pretty awesome actually.
Yeah. This module config defaults that you have, which does like the event, all that. I believe Basti told me that that this part could be eliminated from the macro. So like the macro could discover which types are exposed by the modules, and then this entire one configuration would be gone too.
Yeah.
Oh, that would be really nice. Like this gets solved upstream, and then it's not Steve's problem to solve here, and it's not for people to write like when they're doing this the manual way.
Yeah, that's my suggestion. Is don't only think. I think this is super cool, but if you see some problems, you see some things like hey, like whatever, like definitely question whether or not it's possible to fix it upstream versus having to do all this magic on your side, right?
Oh.
Yeah, that's super cool. This is super cool.
Of course, I wouldn't. This is, yeah. So the idea is that you can pull a module and all the depending module and you get like a default config that builds, and then you can start hacking away.
Nice.
So Steve, if I let's say I've written some runtime module that I think is like fairly useful maybe to other people than me, and I'd like to make it compatible with your tool, do I basically just have to like add that section to my cargo toml and then get it in some registry, and that's kind of the end of the story?
Yeah, that would be the idea. Yeah.
That's awesome.
Yeah. We should get. Oh, sorry, I was gonna say we should get this done for the contracts module. So I think that's the most commonly added module to a new runtime.
Yeah. Sure. So yeah, just to show you, like, because we don't really have like the Substrate 2.0 modules published yet to Craze.io. Like, I actually published like all the core crates and all the run module crates. Like I have 500 crates in there that I published in a semi-automated fashion, and I actually broke the the feature of Cloudsmith for alternative registry. They told me like it was too big. Yeah, they I spent a bit of time with their support because I don't think anyone had tested that yet. But yeah, I pushed like a lot of stuff. Basically, what we want to be able to do is run the add command, and then everything is configured, and then just build. But for now, we still have to add a few things to the cargo config file. So yeah, right now I kind of have to tell cargo that I'm redirecting everything that is referencing crates.io, or everything that's referencing the Substrate repo. I'm actually linking it back to my alternative registry. And yeah, this is not very stable right now. So again, I'm hopefully we don't have to do that when everything is pushed to crates.io.
Mm-hmm. Awesome.
Yeah, so that's basically it.
That's really nice, Steve. Thank you for sharing that. I have a question for you. And I've shared part of this with you, but I had this idea at some point of like, there used to be this really good exercise in Substrate's README where it basically said like, okay, build Substrate, now get your chain spec JSON file, and now there's all these fields in the JSON file that you can edit, and like one of them was the block time, and now recompile and like notice that your node makes blocks more frequently or like less frequently depending on how you change that. And in the like last couple months, as I've been working on Substrate, I noticed that fewer of those like tunable parameters are available in the chain spec because they are all now used with this, oh shoot, what's it called? Parameter types macro. And so this vision of having like a customizable blockchain where you could like almost declare your blockchain out of this config file, I was like, oh, it's kind of getting farther than that. Like I now have to edit Rust code to make more of the changes. And so I'm curious if a tool like this, I almost feel like I could write up a whole blockchain just as JSON or as like TOML or something, like, you know, include, I want these modules in there and etc. And like your tool could generate the Rust code. Like, is that a the spectrum that you feel like you're playing on, or is it more of a specific, like, this is just for adding modules kind of tool, or like, where do you see that going?
Well, I hadn't thought of that feature, so that's a good one. But yeah, right now I'm building all of that stuff in the perspective of building a front end where we can search and get information about runtime modules that have been shared with the community. Also be able to push a runtime module so that we can also run some automated process on those modules, like analyzing them, rating them, I mean, doing some security checks and stuff like that. So yeah, so basically the idea is that we will have portal for searching for runtime modules. If you push it to crates.io, you only get information about the crates, right? But yeah, we ideally we would like to display more information that are substrate specific. Yeah. So, but yeah, what you mentioned, I think that would be great. It's difficult for me to say whether like it should be top priority or not.
Yeah,
I guess maybe Sean probably has some input on that. Yeah. No, maybe I'm gonna stop sharing my screen because I'm on a cellular connection. So
awesome.
The sound's gonna be better.
Cool. Yeah. Well, thank you very much, Steve. That was really really insightful. I can't wait to start using it in practice. Oh yeah, so like if we want to play with it, what can we just clone?
Oh yeah. Yeah, so because I'm actually referencing some branches that haven't been merged in other tools, I cannot push it to crates.io either. So right now you have to clone the repo and then do cargo install on your machine to have it as a binary.
Okay.
Yeah, I need to update the README for that, but that's basically it.
Awesome. Oh, okay, cool. So Adam, you were mentioning in the chat that you might have some info or like some stuff you could share about, let's see, custom origins and signed extension.
Signed extension code that's in the system SRML, I think, and had a look at some of the origin and mucking around with origin that happens in collective and membership modules. So I've had a look at, I guess, like the kind of sample code there for the SRMLs that ship the substrates. And we're sort of looking at how we can use those internally on the project we're working with. So I kind of get some parts of it, but yeah, I guess I was kind of keen to maybe learn a little bit more. There's a few bits which aren't entirely clear to me. Specifically in signed extensions. So my understanding of signed extensions, if I just jump in, is that they give you an opportunity to kind of validate or reject transactions at a very early stage, which is obviously great from a kind of network spamming perspective. And that's fairly clear. The bit that's less clear to me is there's this associated type called additional signed, and a function that's part of the signed extension trait that returns something of that type. That's the bit. So it seems to be a way to inject other data into the signed payload, but I'm not quite sure what the intention is in terms of where you would use that data that's injected, or how that is that available when you by the time the transaction makes it to be extrinsic or not. So that's quite fuzzy at the moment in my head. So I guess I was more aiming to learn more about it, if there are people on the call that had more experience or knowledge about that area, rather than me demoing something.
Sure. Okay, cool. Yeah, that's super interesting. Some of the intro you gave there is already stuff that I would like to know more about. I'm curious, does anybody feel like they could shed some light on that, or also? Yeah, go ahead.
Yeah, I've looked at signed extensions in 3 forms. One is the fees system. The other one is I was building a fee system for my own runtime, where I built I forget what it's called, an alternative token thing. So I was paying using tokens to pay for fees on transactions. And the last one was recently in the Parathread auctions. There was a signed extension being used in place as an auction mechanism for transactions. So I mean, I've definitely touched a lot of the code. I'm not saying I implemented everything myself, but if there's something specific, or maybe we can walk through one of the things, we can talk about how it works.
So maybe as a jumping off point, I'll just share my screen and we'll go to a relevant section. And does that sound like a good idea?
Yeah, totally.
Sure. Yeah.
To be honest, I'm still not sure what is signed extension.
Yeah. So okay, cool. So maybe we won't get to a level where Adam learns much, but we'll all be kind of up to speed with him at least.
Yeah, it's all good.
Oh, whoops.
Yeah, I think the summary of a signed extension is that there's additional data attached to the end of a transaction or end of an extrinsic, which you can define and your runtime can interpret, and your runtime can use that data to basically process through what we call a validate function. And this validate function can pretty much do anything, but most often it's used to either set the weight, like the priority of the transaction before it hits the transaction queue, set whether or not that transaction is valid or not to begin with, or even to manipulate some parts of the storage or runtime, or I don't know, something like that, right?
So it is extension with some auxiliary data, which goes also into validation function.
Yeah, and I think my best understanding, and this might be an oversimplification, is that basically the extrinsic payload has is well formed, and signed extension allows you to add more well-formed data to the end of it. You can just keep adding more and more signed extension data as long as your runtime knows how to interpret it.
So one place I just searched for signed extension, and one place I thought oh, I know a little bit about that code, maybe we'll jump off there, is here in the node template.
Yep.
I'm in node template, and I think I'm in runtime source lib. Well, let's see, what file is this?
Yeah, you're in lib. Yep, exactly right.
Oh yeah, runtime source lib. Yeah, right. Okay. So after we did all of our construct runtime and all that stuff, then there's some. Well, yeah, then we create this type signed extra. So that's actually, the comment is it's the signed extension to the big transaction logic. And then it looks like maybe we could just add more and more lines here, I guess, as there's more things we want to. And so here's a super dumb question that I think I know the answer to, but I'm honestly not even sure. When we're talking about the extension, what we're extending is the transaction, right? When I submit a transaction to a node, we're extending it with this information. Or is it does this go on a transaction or a block, I guess, is what I'm asking.
This goes per transaction.
Okay.
I believe again, I don't even know exactly at that level, but my belief is that yes, the transaction payload can have additional bytes at the end, which is processed in this way.
Yeah.
You can see it if you go 3 lines further down. 309 takes is a checked extrinsic, so a extrinsic, and that contains the signed extra.
Mm-hmm. Yep.
Okay.
So you can see it has a count call and then the signed extra. So this is the additional bytes.
Okay, I see. And so what makes it checked? We've confirmed that some things are valid at the, unchecked is right here, I guess.
So, it's both the same. So checked and unchecked basically basically is like parts of the execution. And actually, I think I wrote about this in one of the new docs coming out, but it's basically an extrinsic goes through like a validation function, and then it's checked or not checked. So once it's been checked, it's known to have executed correctly. Like there isn't a flaw in what the transaction is trying to do.
So yeah, I see we go from like when we have unchecked extrinsics, the type parameters include an address and a signature. But then when we come down to checked, we don't have those anymore. And instead we have an account ID. So that makes me think like it probably in addition to other stuff or maybe not, but like at least we've verified a signature at that point. Maybe.
Yep.
Yeah. Okay. Cool.
So Sean, do you know, so if you do add, so for example, one of these, I think the checked version signed extension, which is referenced on line 299, adds a runtime spec version in the additional signed function. Whereas is that somehow injecting? So by the time you're in a extrinsic, you have this origin.
Well, actually, I think these these first 5 are actually a little bit different than the others because I don't think these first 5 actually expect additional payload data, if I understand correctly. I believe there's some kind of hook which checks these things, but it's not checked within the payload itself. This 6th item, 304, actually does have some expected input data for it.
Okay, so maybe that would be an interesting example to look at. I guess the bit that I'm a little bit confused by is whether by the time you're in extrinsics, let's say you're building a new SRML, I don't know, let's say game or something like that, and you have these extrinsic functions which are constructed using the dep module macro. Are those extra payload, like is that extra payload data available somewhere inside that extrinsic? Is it somehow part of the origin parameter, or?
No, that extra payload data is only accessible, to my understanding, through this signed extension validate function.
Okay, I see.
So maybe we can look at that. Give me a second. I have to open up some code on my side. Maybe I can share screen.
Let me ask a question real quick before I ditch this one. So like looking at this last one here, I know that transaction payment is a module and it's a module that's in our runtime. And so like, I guess if we flip over there, maybe we'll see this charge transaction payment struct or whatever this thing is. And then it's going to have some logic that like makes sure we can pay the fees or else the transaction fails or something like that.
Yeah, I mean, if you go to that module, I would expect to see there's a implementation of the signed extension trait, and there's a function like fn validate.
Yeah. So okay, so we're looking for like charge transaction payment or something. So here's the struct charge transaction payment, and oh yeah, and it has a method. Okay, from. So this is going to construct an instance, I guess. Oh yeah, so it only has one field, which is a balance.
Yeah, but you can see this is the more important part is this implementation down here. So there's implementation, and then if you go scroll down, there's a function validate.
Yeah. Okay. Oh wait, sorry. What was that?
Yours is looking a little different than. Let's see.
So I think somewhere down below you should see an implementation of the sign extension trait for that struct type.
Yeah, implementation sign extension for the charge transaction payment. This is the important part. Because what you're showing here is just implementation of functions on this struct, but what you really care about is search fn validate.
Can you say that again, please?
Fn validate. This is it. So the implementation of signed extension for this struct.
Okay, I see. So, right. So before that was just some struct. I can make like any struct I feel like that has maybe some methods and fields or whatever. But now here's where we're saying this struct that we were just looking at before, which was kind of interesting, is going to have these properties that it's able to be used in the signed extension feature.
Yeah, and I think the main one is that it exposes a function called validate, which will return transaction validity.
Okay, nice. Yeah.
So let's talk about this function. So what this function is supposed to do is, along with a transaction, you can pass additional information about how much tip you want to give to the person who processes your transaction, right? This is supposed to increase validators to add your transaction to transaction pool, like just like increasing the gas fee you would do in Ethereum. And so the end goal here is that you pass some parameter, And this signed extension thing is going to look at that extra, whatever, like extra fee tip you want to put, and then increase the transaction weight of your transaction proportional to that fee. And then when it goes into the transaction pool, it will automatically be at the top, or higher compared to other ones, because its transaction weight was already increased. So now with that in mind, maybe we can walk through the validate function.
Yeah, okay, cool. So it takes an instance of this struct that we were looking at. It takes, like, I guess who's sending the transaction, probably. It takes what transaction, like what extrinsic it is we're trying to call.
Yeah, we still don't use it here though, right?
Oh yeah.
In this case, we don't care what we call, right? We just want to see if the transaction goes up, but you have access to that data.
Right, okay. So then we have dispatch info, and dispatch info includes the transaction's weight and whether it's normal or operational. And then I guess this is length of the transaction in bytes, probably.
Something like that, yeah.
Okay.
And then you can see, yeah, yeah, keep going.
So yeah, okay, cool. So it's going to give us back transaction validity, which I'm guessing is some kind of enum that it's like either valid or it's not valid. Okay. And so then we just say like, okay, we call that compute fee function. So this is going to be like the fee that we owe for this thing. Imbalance. Let's see.
Yeah. So yeah, I think the thing here is that a compute fee is a function implemented on the struct that you can call, and then the data that we use to compute the fee is of course passed as a part of this object, right?
Yeah.
I have a small doubt. So in the signed transaction, the extra information which is sent is that the dispatch info that we're taking into info, and by that we calculating the fee. Am I right?
From that, we're calculating the fee.
No, the from what we're calculating the fee is this self.0, I believe. I think self.0 actually contains the actual.
So just in case anyone doesn't get the Rust syntax here, self in this case refers to this struct like charge transaction, or then actually it's a specific instance of that struct, and .0
I got that.
The zeroth field, which was.
I got this. I was just I thought there might be some random function or some randomness in this, because fee cannot be constant at all time. It have to change. So on which parameters they will depend.
Sorry, I missed a word. You said fee cannot be what?
So for every transaction, for every signed transaction, I think the fees wouldn't be same. So the parameters on which the fee will be dependent are the length, the info, and the self.0, which is like it is coming from charge transaction payment.
Yeah, I think you're saying, yeah, you're right that every transaction is going to have its own charge transaction payment, which is going to have its own value. So every single transaction is going to have its own signed extension, which will have this form, and will have different values. So this validate function is processed for every transaction independently, and and the final result here, where the weight of that transaction is modified for just that one transaction, right?
Okay. Yeah.
Okay. So yeah, so there's a compute fee function. We can imagine as a black box. It takes this numbers, inputs, and outputs some fee. The imbalance thing here basically is we're withdrawing from the count directly this fee value, right? And of course, we're keeping it alive. Like we don't want someone to pay a fee that will kill their account. And we of course save that in the imbalance, because this imbalance will keep. If we don't use the imbalance, it will correctly manage the total issuance, right? But in this case, we will.
Question.
Yeah.
I'm not sure. Why are we going to get an imbalance here? That's what I wasn't really clear on. Because you're taking something out of a user's account, right? Like Josh, you have. And it's not going to. I just assumed it was going to like a validator or.
Well, it will.
Yeah.
It will. It will. So later it will, right? So, but right now you're just withdrawing. So we're not calling transfer. Transfer would not have an imbalance. We're calling just withdraw.
Yeah.
And you can see here we have a handler for the imbalance. So this on transaction payment, I believe it does some magic, which basically it will pay the current validator. So like in this logic, we don't know who the validator is.
Yeah.
Right? We don't, but this on transaction payment has the right thing that like whoever the the current validator who's producing this block is will get this imbalance.
Yeah, I see. Okay. Oh, yeah. So this is going to be like somewhere we implemented a module's configuration trait and we like wired up the right thing that says like whenever there's an unbalance, like handle it here. And so in the code we're looking at now, we don't handle it. That's somewhere else that also handles any other imbalances that might pop up in the chain.
Yep.
Okay.
And then if we keep going down, the valid transaction is default. And then you see priority here. We just take the fee and we turn it into priority. So the priority of a transaction is exactly equal to the fee that you're paying. So if I'm paying 100 and you're paying 101, you will have 1 point more than me. And whatever that means in terms of transaction queue, in terms of ordering, that's what it does.
And in practice, at the end of the day, it probably means that if there's like a lot of transactions, mine with the higher fee will go in first.
Yeah.
Okay, cool.
So this is one example. Questions about this? Because the next one, I think it would make sense to then look at a more complicated example, which is the one I was referring to in the Polkadot runtime.
Do you want to share it, or do you want to tell me?
Yeah, I mean, I can share, or you can go. It doesn't matter to me.
Yeah, go ahead.
But first, let's make sure. Are there any questions about what we looked at? Yeah, I'll share in 1 second.
Okay, cool.
So no questions, right? Sorry, I need to update my.
No questions, I guess. Whilst you're setting up your screen, Sean. So with the example we just looked at, it seems to be the most common approach where it doesn't use this additional signed type. I think like we looked at that example, the type additional sign is just set to like empty, and the function additional sign just returns like okay or something like that. So you can see just above that, the function additional sign is basically a no op, it just returns okay. And then the type of additional sign is just, so like on line 510, the type of additional sign is for empty, or whatever we call bracket in Rust. So that's what, and that seems to be the most common example. And in fact, in the documentation I found, there's not a lot of information around that additional sign. So I guess I was just kind of trying to understand. So there is one example of a signed extension that does use that, which is the check era signed extension. But that's the bit I kind of can't quite grok, is why, like, when is that additional sign used and what would you use it for? That's definitely one thing which seems like a bit fuzzy in my head. The additional sign type is included in the signed payload, but I can't kind of see where it's used, if that makes sense.
Yeah, I'm not sure myself, honestly, right now, but that's a good follow-up question. We should definitely follow up. Definitely documentation around this is not there because it's a pretty new feature, to be honest. But yeah, so your main question is like, when do we use this additional sign and what does it get used for?
Exactly, yeah. So the kind of combination of the type and the function.
But again, I'm trying to understand, maybe it would help to put your needs into context. Like, what is it that you're looking to do and why do you think this feature is helpful? And
I can do that, definitely. So let me try and sort of cast it in relatively general terms. But so what we're looking at is that we want everybody who submits a transaction to the blockchain to have certain data associated with them. So let's suppose it's not actually the use case, right? But suppose you want everybody who submits a transaction to have declared their name and address, their real world name and address. Then one way to do that, it seems to me, is to have a signed extension which checks that as early as possible. So a signed extension whose validate function checks that the account ID somewhere in some storage in some module has like a first name and second name associated with it. And if it doesn't, you reject the transaction. If it does, you just you proceed, basically. So very similar to the way the check nonce signed extension works, which checks the nonce of the incoming transaction is valid before it lets it proceed. So that kind of makes sense, and that seems quite easy to do. I guess what would be nice is if so in this example, if the user's first name and second name was available in a natural way to all the extrinsics. So rather than every extrinsic having to kind of go and regather that data for that first name and surname set of associated with account ID to be available to extrinsics. And that's what I was wondering, whether if somehow I injected that, if say the type additional signed was vet U8, and and we set it to be, say, the person's first name, whether that's then somehow like accessible in runtime modules or something like that. But I may have just understood, I may just have misunderstood kind of what that additional signed data is there to do.
Yeah. Again, I'm not gonna be able to. I don't think I'm gonna be able to give you a confident answer right now. So I would rather shy away from saying something that's wrong than So I think it's good to follow up here. In general, what you're asking sounds like something that's doable. So I think that you're definitely on the right path, and this is the right thing that you'd be looking for.
And I guess so in the chat, the reason I was asking about sign extensions and custom origins is that custom origins seems to be another way to potentially try to solve this problem, where you use a newly defined raw origin, which say maybe includes, in this example, somebody's first name, and then all of your extrinsics use that newly defined raw origin rather than the kind of default origin. So that seems to be kind of two, so like kind of redefining what origin is seems to be one way of kind of tackling this type of problem, and then sign extensions seems to be another way. And I'm just trying to kind of figure out how to put those pieces together.
Yeah, I'm not sure you can actually, from the outside world, call into your runtime with a custom origin. I think from what I know about, or at least what I've seen with all the patterns within Substrate and Polkadot, is that always the origin, if it's custom, is getting generated within the runtime itself. So, for example, you have the governance module creating a new origin, which gets called into whatever it does to execute the new governance proposal, or you have a parachain from within the runtime calling with the parachain origin. But I think from the external world, you either have a signed message, a inherent, or and that's it.
Yeah, that makes sense. So that definitely makes sense. So what I guess one way to engineer it, and I'm not sure this is particularly a good idea, right, would be to have a single extrinsic, say, called execute.
Oh, sure. I see what you're saying. Yep.
Everything comes into that single extrinsic, which then which takes an underlying, like an underlying kind of function to call, and then calls that underlying function with a custom origin. That might, I'm not sure that's a good way to do it.
I think that what you're describing would also be a hack that would work, but the sign extension definitely seems like the better approach.
Yeah, exactly. Yeah. So this is exactly the sort of analysis we're trying to figure out at the moment.
In the scenario you just outlined with the custom origin, is your thought basically like the real extrinsics that are somewhere, that in your hack is not written as extrinsics because there's only one, but what would be your real extrinsics are just there as regular functions, and once you've done those couple checks that the user has actually listed their name and address or whatever, then you call into the actual thing with this custom origin, and it already knows it's good because it has the right origin.
I guess so. You could have the real extrinsics still be extrinsics, but usually the first line of every extrinsic is ensure whatever it is, ensure origin.
Ensure signed,
sorry, ensure signed rather. And so instead of having that, you would have a type on your module which so ensure origin is a trait, and you can implement implement a custom version of it. So instead of having ensure signed as the first line of each of your extrinsics, you'd use a custom implementation of the ensure origin trait, and that would check that that the origin passed in by this proxy function was good in some way. But you're right. I guess if none of those functions are ever going to be called directly from outside the blockchain, maybe they don't really need to be extrinsics, right? Because they could just be internal functions. They could just be non-extrinsic functions. But the pattern I saw on the kind of collective module and things like that was to leave them as extrinsics, but rather than kind of calling ensure signed, to call something which used a sort of custom ensure origin trait.
Mm-hmm. So Sean, which one is it you're
again, I think this signed extension is definitely the right approach for you.
Okay.
Yeah, so the other example I wanted to show you, the other thing that I worked on was for pair threads. So one of the parts, I'm not sure, I won't go into detail about like all the stuff about pair threads, but the idea is pair thread is this ability, is like a lighter version of a parachain where if there are slots available for people to make, proofs on the relay chain, you can basically auction slots for people to kind of dynamically just like say, hey, I want to have my finalization on the relay chain, and people who go through this auction can basically get their slot in there, and there's this limited number of pair thread slots available, and basically you don't have this like long-term commit of collecting a ton of dots that you have to commit for being a parachain. Instead, you just pay for the times and the slots you need. It's kind of be like a much more approachable access to this Polkadot environment. And the idea that they do here, and this is actually, I think, really quite clever, is they built the auction system within the signed extension itself. So the way that this works is in combination with the fee system, which I showed you previously, the transactions get ordered with a certain weight. And then in this case, the first X or N people who asked to be part of this auction will get a slot. So I guess the way to think about it is that you have, let's say there's 5 slots and there's 10 people. Everyone would submit a transaction to this one function. It's like a dummy function. Let's see if I can find it. With a different fee. And here is the function, select pair thread. Place a bid for a pair thread to progress. And you can see that it's a dead function. All it does is ensure signed and doesn't use any data here. And out of the 10 transactions, the top 5 who paid the highest fee, who go into the transaction queue first, will then go through this function, this signed extension function, and basically fill up the 5 slots and then invalidate all the rest of the bids. So you see anyone who calls that function, so you see in this case, actually, we use the call here. So anyone who calls that function will have a transaction with that call. We'll go through this process to validate. We first check that the call is the call that we want it to be. So it's the select pair thread call. So is the transaction we're processing, you have the correct call that we want? If it does, first we check some validation stuff. Then we basically check to see like, okay, how many threads are available? If we're not over the limit, add them to the list. And then anything, and then make sure they're not duplicates, make sure that it's a live bid. There's a bunch of like, just validation stuff, but ultimately, if there's a slot available, put them in there. And if it's not, if there's like not enough slots available, then we say that the transaction is invalid with the enum exhausts resources. And at the end, we do okay. So you can see here, this validation function, this signed extension doesn't actually process any additional signed information. We don't actually have any data in our transaction, which is extra. We just have the data from the call, and we have the information about the call itself. And we know that there's already some processing happening by the transaction fees on the order of the transactions here. This one's a little more complicated. I'm not sure if I explained that well, but does that generally make sense?
That makes sense. So, and you use pattern matching to make sure that you own. So basically, for any call which is not a select para thread, this is a no op, basically, right?
Yep. So this is if let this, and if this doesn't pass, then you just go to okay.
Yeah.
Right. So so any other transaction would skip this validate function. It would be okay. Yeah, and you can see here the validation transaction is default to begin with, so you'll return R. So it'll stay the default.
So for a function, so for a call which is select para thread, the side effect is what? So it does some checking to make sure that there's there is a free para thread or whatever, right? And that so it does some checking. Is
slots are available and stuff. Yep.
Is there like any other side effect in terms of, so it looks like you are writing out 555 does some.
Yeah, actually we write to storage, if I'm not mistaken. We actually write to storage. So, and we have to, because this is how we keep track of the number of available paired thread slots. So let's take a look here. So you can see we're calling to our module, we're calling some functions. Somewhere I'm looking here, get, thread count get. So this is at least one call to storage.
Okay.
right?
So you're
and then
reading and
selected
writing.
threads up here is also another read to storage, selected threads.get. So if we wanted to go look at here, we do selected threads. Let me just do declare storage. You can see here the selected thread, which is the vec of a vec of this. So we can read and write into the.
So then another, maybe, again, this might be like the hack category. So possibly another way to solve the kind of design thing that I mentioned earlier would be to have a module with a storage slot called first name as a string or whatever, vector U8, and then have the validate function write out, for every transaction, write out, to figure out what the first name is of the calling account ID and write it out to that storage. And then every other module, right, once you're actually executing extrinsic, you could just have a look at that storage slot and see what the current first name is, and effectively that storage slot would be overwritten for every single transaction. Does that make sense?
That seems reasonable. So you're saying you have a custom module, and in this module's purpose is basically to store the first name. There's a validate function at the very beginning, which will extract the name, and then every other module uses that storage item for all of its purposes.
Yeah.
And then basically that item gets cleaned up at the beginning of every
transaction. May have a different first name. So I guess either at the end of every transaction or at the start of every transaction, you kind of click.
I don't know about yeah, I think at the end of every transaction is possible. Yeah, I don't know exactly the details. There's a little bit of finessing here because the way that every transaction gets processed twice through the executor. One time to validate like this checked and unchecked thing. So like one time it gets processed just to validate that it's a good transaction, and then the second one it gets processed to actually write to storage and make changes and stuff.
That I was wondering about that too. Like especially now that you're looking at storage in here, because if we think about like regular transaction execution, once it's in a block and I'm just like validating a block or something, then I have like a total order over my transactions. So the storage values I'm reading are like whatever the storage values were when the previous transaction finished, like as mine are about to get going. But if like validating the extra signed stuff happens like when a node first receives a transaction, like, it's not even put into a block yet or anything, like whatever storage value it reads then is not necessarily the same storage value it's going to read later once this extrinsic is included in a block and goes to be executed, something else might have mutated it in the meantime.
My understanding is that, and again, there's a little bit of not magic, but like a lot of good engineering happening here. But the first part where it validates a transaction does, no matter what the code says it does not actually touch storage. Like it does not actually write past the cache into the actual database. So the validate function doesn't actually write anything. So it just validates.
That's interesting. So it's like a dry run, and it says like if everything went okay in this, when I did this dry run, like great, go ahead and include it in the next block, and then we're actually going to run it like during the normal execution.
Yeah, and I believe I documented this in execution or something. It's coming. I mean, I'll post a link to the doc in the Substrate technical channel. But
cool. Is this callable from the client, sort of like gas estimate equivalent, where it can actually run the dry run?
Is this callable from the client?
Like, you mean like
gas estimate?
You mean like if I'm writing a front end for a DApp or something, can the front end make this calculation for me before I have to go ahead and bother a node? Like, can I determine on my own this isn't going to work, or something different?
I think you would need to have the equivalent Rust code somewhere implemented in your JavaScript, right? Like
whatever your DApp use is. But I mean, sometimes I just like to run these things before I even.
Yeah, like there's no reason to send it across the network and wait for someone else to tell you that it's not going to work if you could have checked on your own first.
That's exactly it.
So I posted a link in the chat. I should post it in tech chat like Sean said, but I posted it in the Zoom chat at least. And the Polkadot.js docs talk about signed extension a little bit. That was actually the first time I encountered it. And so I think Polkadot API does something like that, because it can say stuff like, this isn't going to work because the nonce is too low. But I'm not really clear whether it does that on its own or if it does query a node first.
I believe it does that on its own.
Yeah, that's pretty nice.
Actually, I do think the runtime API though does expose a validate transaction function. I probably can find that here. Let's see, runtime API. Implement runtime APIs, and here there is validate transaction. So
can you give us some context, Sean? What file are we looking at here? What kind of
stuff? We are in runtime librs, and so every single runtime must implement runtime APIs. Basically, this like Substrate is a bunch of separate components. The runtime is completely separate from every other part of Substrate, like the database, the consensus, the networking, all that kind of stuff, right? And so it exposes a set of APIs which other parts of the Substrate can call to actually do things, right? And I believe that even some of these APIs you can expose yourself to be called through RPC. So like once you have a runtime API, you can probably expose it through an RPC API or whatever, right? And so one of the functions that is exposed through the runtime API is validate transaction, which I believe is exactly the function that gets used when this validation function happens. And so again, I don't know through the RPC if this function is exposed or if it'll be well formed at this point, but it seems very possible that you could query your runtime to do this one function call.
Yeah,
I will test it. Thank you.
Yeah.
Hey, I wanted to say also, there's an example of one of the other signed extensions is like check Genesis and one's check era, and those ones actually do use I forget what it's called, like the extra data or whatever that was, signed additional or additional signed, I think.
Oh, do they actually use extra data? I thought last time I looked, the first 5 were like all like empty.
Oh yeah, I mean, but well. Yeah, here, the place I'm looking at is actually like, sure, yeah, that's fine. I could do that, yeah. So I don't, we'll just see if this is like super relevant, but like the one that I was looking at here was check Genesis. And so having not even read the code yet, my understanding of what this does is when I compose a transaction, along with that transaction, I send the hash of a Genesis block. And the reason that I do that is to say like, please don't play this transaction on any old blockchain you know of. Like I might not want to transfer token on some random blockchain. It's specifically for the blockchain with this Genesis block.
That's correct.
And so that way it only goes like to the right place. So the additional signed data that I attach there is a hash, and this is going to be the hash of the Genesis block. So like this would be where the first name was attached or whatever. What I haven't done yet is like look and see how they actually go ahead and validate that though here, but we were looking earlier at, oh wait. Yeah. Oh, that's the whole thing? Yeah,
no,
so we actually
there has to be an FN validate, right?
Yeah, where's that at?
Can you search FN validate?
Yeah, there might be a lot of them. But shouldn't it be an impl signed extension or no?
You can do multiple impls of the same thing, right?
Oh, I didn't know that. So there's one. That one's for check wait. This one's for check nonce. This one is for check era. Check. Oh wait, are we back to where we started?
So maybe there's a default implementation somewhere. So like if it's not being defined, then the signed extension might have a default implementation. Which
so let's look for that here.
Up, right? Yeah, what's confusing to me, sorry, just while you're putting it up, is that it seems in one situation they used the additional signed as the way of transferring data, and then the other situation they used the struct itself, right? The zero of the balance, right? And that, okay, well, I need to learn myself more.
Different. Yeah, that's a good observation. Okay, so let's see here. Required methods. Oh, this is the one we were looking at.
Okay. So it already has the implementation of this.
Right. So for the one we're providing our own, but yeah, so there is going to be one here. So let's see what it says. Validate a signed transaction for the queue. Okay, that makes sense. The function can be called frequently by the transaction queue to obtain transaction validity against current state. It should perform all checks that determine a valid transaction that can pay for its execution and quickly eliminate ones that are stale or incorrect. Make sure to perform the same checks in pre-dispatch function. Okay. Should we look at the implementation here, I guess? Oh, I thought there was a link where we could like go see. Well,
There
okay,
is,
that's
but-
okay. It's in SR primitives traits, so I can
Mhm.
get this there. So that's in core, I think.
Yep.
Runtime, there we go. SR primitives, source, traits. Signed extension. Okay, let me get the zoom thing out of the way. And that out of the way. Whoops. That's not it. Okay, nope, that's not it either. There we go. Okay, so trait signed extension, and we were looking for the default implementation of validate. So here it is. These are the docs we just read already. And that's the implementation. That's, I mean, that seems like it doesn't do anything,
So,
right?
I mean, this is exactly what the default implementation should be, right? It returns.
Yeah, it just says it's valid. Okay, yeah, you're right. That's true. So the reason I chuckled though is like, did we actually validate that Genesis hash, or what's up with that?
Again, there's probably there's more under the covers than we know right now. Like, it could be, for example, that maybe that sign extension, that part of the inclusion of Genesis hash gets used somewhere else in the runtime logic, or transaction processing logic, but is used as a sign extension just to have the data there and be available. Yeah. I'm making a guess, right?
Yeah, it's like an informed guess, something like that. Yeah.
I mean, we could do a hunt, but it seems like we're a little bit over time. I mean, it seems like a really good follow-up here is that we should get either one, ourselves informed on this and do a talk next time about side extension, or get someone who is informed and have them school us.
Yeah, nice. Okay, good. So yeah, it is after the hour already. Does anybody have anything they want to share or comment? Probably not something that would take like 20 minutes, but you know, in the 2 or 3 minute range would be fine still. Okay, cool. Well, big thanks to Steve for sharing Substrate Deps, and big thanks to Adam for getting us on this interesting topic. And of course, thanks for everybody for attending, and Sean for sharing your screen and your knowledge.
Of course.
So, okay, cool. Well, I look forward to seeing you guys all next time.
All right, thanks, guys.
See you later.